Our objective for today, I can simplify exponential expressions with fractional exponents. Let's read it together. 1, 2, 3. I can simplify exponential expressions with fractional exponents. So, you wrote that down at the bottom left. And if you notice, we're still on the same concept. Tell your neighbor the concept we're still on. Exponential expressions. We haven't left. However, today we're starting with the exponents are what? Fractions, your favorite. Yay, fractions. Notice that it's getting a little bit rigorous as we go along, right? Okay, we started with regular numbers as exponents. Now we're going into fractions. Yay. All right, here we go. So, we know what exponential expressions are. We took that, we started with those this past week, right? And we know that they are numerical and variable expressions raised to a power greater than 1. These are examples, non-examples. Here's the critical attributes. They have to be expressions only, and exponents greater than 1. Okay? We need steps. Copy these down, please, underneath your Fourier model. Step number 1. If the exponential expression has a fractional exponent, then rewrite as a radical and factor the number completely. Some of you are saying, like, what do those things mean? Well, I'm going to clarify that a little bit, but write it down. If the exponential expression has a fractional exponent, then rewrite as a radical and factor the number completely. If the exponential expression has a fractional exponent, then rewrite as a radical and factor the number completely. Step 2, identify the index of the radical to find the root. Step 3, raise to the power outside the parenthesis. And step 4, simplify. Okay, copy that. Okay, here we go. It says, I'm going to go over some of the terminology, and if I give you a definition, I want you, or a small example, I want you to write it on the Q side, right? And then just point to the word or point to what we're clarifying. Okay, here we go. Let's see if we understand most of the step. It says, if the exponential expression, do we know what an exponential expression is? Yes. Has a fractional exponent. Do you know what a fractional exponent is? An exponent that is a fraction. Okay, so far so good. Then rewrite as a radical. That one we need to clarify, right? So check this out. To clarify with blue, I want you to put this symbol over that word. Before, you used to know that as a square root. Remember that? Except for, in the past, you only used to find square roots of numbers. Today, we're going to be finding several roots, like cube root, fourth root, fifth root, 23rd root. Ah, pretty good, huh? So therefore, we no longer are going to call it square root. We're going to call it a radical. Everybody with me? All right. Next, I want you to circle with red the word factor. Draw an arrow to the left side on the Q side and write this down. Factor. Put a little star, a heart. Aww. Numbers that multiply. Or numbers that are multiplying. I'm sorry. Multiplying. Numbers that are multiplying, or numbers multiplying. Let's see. If it says numbers, could it be only one? Numbers? No, it has to be more than one. Is that correct? So as soon as you see numbers multiplying, they're called factors. Everybody with me? All right. So let's see. So now we know the first step. It says, if the exponential expression has fractional exponents, then rewrite as a radical. We know what the symbol looks like. And factor the number completely, which means we're going to find out numbers that multiply to get that number. Step 2. For step 2, notice this. Identify the index. So does everybody know what an index is? You're like, yeah, we use the index cards. No, we're talking about math. Index. On the Q side, once again, circle the word index with green. draw an arrow to the Q side, and you're going to write this. Everybody look up. You're going to draw a radical first with blue, and you're going to write a little number outside the radical like this. That number is called the index. The little number is called the index. Now, once again, compared to other years, you're saying, I never saw that before, Mr. Q. No, because compared to other years, you guys used to focus only on square roots. Remember that? And the square roots, everybody look up, the square roots didn't have an index because they assumed that you knew that. Check this out. If I gave you this, everybody look up, please. If I gave you square root of 9, what are you going to say? How do we get 3? Multiply a number times itself. How many times? 2 times. That means there's an invisible number here. What would that number be? 2. No, 2. This is indicating how many times you're going to look for a number multiplying itself to give us this number. That's what the index means. Everybody with me? So far, so good? Yes. All right. However, today we're going to look for numbers that multiply themselves. For example, this one will multiply itself how many times? 4 times itself. Everybody with me? You'll see it right now. Step 3, raise to the power outside the parentheses and simplify. Okay? So, with that said, turn your paper over. And just to emphasize, we're still practicing the math practice standard number 6. Which one? Math practice standard number 6, which is a 10 to precision. So that's why I was calling on some of you that turn in your homework to make sure you focus on those negatives, get them out of the way. Send them to the denominator, or those that go in the numerator to the numerator. So be precise with your work. Here we go. Don't copy this down. I'm just going to clarify some vocabulary that I'm going to be using throughout the lesson. This one. Prime numbers. In case you forgot, I remember you guys were introduced to prime numbers a long time ago in the galaxy far away. And they said numbers that have factors, numbers with factors of 1 and itself. Let's see. 2. What 2 numbers multiply to give me 2? 1 times 2. 3. 1 times 3. 5. 1 times 5. 7. 1 times 7. 11. 1 times 11. Are there any other numbers that multiply to give us that? No. Without getting into fractions, no. Are we there? So my first 5 prime numbers are 2, 3, 5, 7, 11. 2, 3, 5, 7, 11. The first 5 prime are 2, 3, 5, 7, 11. The first 5 prime are 2, 3, 5, 7, 11. Now composite, what are those? Well, they're the opposite, well, not the opposite, but something that is not a prime. So these only have factors of 1 in itself. These have other factors aside from 1 and itself. And let's see. Check this out. Look at number 4. What 2 numbers multiply to give me 4? 2 times 2. How about 1 times 4? Yeah, right? So now notice that this one has more factors. These only had 1 and itself. How about 6? 1 times 6 or 2 times 3? How about 12? 1 times 12, 2 times 6, 3 times 4. Does that make sense? These are called composite numbers. Composite. Prime, composite. We're going to be working with prime, and I just wanted to clarify so you know what they are. Okay? Let me continue. Okay, prime factorization on the Q side. You can fit this next underneath where you wrote some stuff, right? Right, prime factorization on the Q side, on the Q column, at the top if you want, so you have space. Now I'm going to take you back to when you were, this was in, I think, in 4th grade. Okay, kids, today we're going to do some prime factorization. Or we're going to start with a little tree. Draw a little tree, people. And then you drew a tree, right? Something like that. And then like that. And then the teacher told you, it's a pine tree. Okay, never mind. All right. All right, here it goes.
Oh, that's better. Oh my God.
Do you guys see it? All right, my goodness. And then your teeth. Yeah, that's your trick. Yeah. No, you don't drive. I'm just taking you back in time. And then they said, start with a number, let's say 30. We're going to start with the number 36, and we're going to do find factorization with a tree. Remember that? Okay, well, today I don't want to have branches on both sides of my tree. This day we're only going to have on one side of the tree. Okay? So check this out. How do we do prime factorization? Let's see. From this point forward, I want you to start with a prime number. From this point forward, I want you to start with a prime number. Before you used to do this. 9 times 4, this is 3 times 3, this is 2 times 2. But then all of a sudden, if this was a bigger number, then you end up with two different branches over here. And that's where some of you started making mistakes. Today, I want you to start with the first 5 primes. 2, 3, 5, 7, and 11. You need to start with one of these in order to come up with like 2 factors. So let's see. I'm going to start with the biggest one. 11, does that divide in here? No. 7? No. 5? No. 3? Yes. So that is 3 times 12. But 3 is a prime, so I circle it, and I don't do anything else with it. Look at 12. The 12. 11? No. 7? No. 5? No. 3? Yes. This is 3. I circle it, and this is 4. I don't do anything with 3 anymore. Look at 4. This is 2 times 2. So check this out. I end up with 3, 3, 2, and 2. This is called prime factorization. What did I say the word factor meant? 2 or more numbers that numbers that multiply, right? So check this out. What is 3 times 3? Times 2. 18 times 2. That's what it's called, prime factorization. You're like, so no. Math is actually really cool if you understand it. Okay, so here we go. So now, let me clarify the term. Look at this, 3, 3, 2, 2. Are these numbers here? Yeah, the 2 and the 3. And what are these called? Prime. So therefore, this is called prime. And are they multiplying? That's why they're called prime factors. That's why it's called prime factorization. Are we there so far? Okay, copy that, please. Okay. The back side of your paper, here we go. I want you to write example Q. Example Q. Write this down. X to the 1/2. What was the first step of our note? It says, if the exponential expression has a fractional exponent, write it as a radical. Remember that? Okay, so check this out. Let's do step 1. I'm just going to show you step 1. Whenever you see any number to a fractional exponent, I'm going to start with this one. This one becomes square root of x. If I wrote x to the 1/3, that becomes cube root of x. If I wrote x to the 1/4, that becomes 4th root of x. If I wrote x to the 1/5, tell you never what that becomes. 5th root of x. Dot, dot, dot. If I wrote x to the 1/23, what does that become? 23rd root of x. Yes. And very good question. Here it goes. And that usually happens every time. Which is the only one that does not have an index? 2, because we already know that this is the square root. that it's a number times itself how many times? Twice. Everybody got it? You don't have to write anything. If you want to write it so that you remember, that's fine. Everybody understand? So, because it's a square root. Square root. What are square roots? A number that we get from multiplying a number times itself. How many times? Twice. Okay? All right. You're saying, I'm a little iffy, Mr. Q. Okay? Pens down, eyes up here. Let me use numbers to see if you catch what I'm talking about. Everybody look up, please. Pens down. Okay, here it goes. Instead of writing an x to the 1/2, I'm going to write 9 to the 1/2. Don't say it out loud. How would I rewrite that in a radical form? Who thought square root of 9? Okay. Now check this out. The next step. Step 2 says what on your notes? Identify the index of the radical. What is the index here? Invisible. 2. Step 3. What's it say? Okay, so step 2, we're going to find the root. So how do we find the root? By using find factorization. So this is 3 times 3. So this could be rewritten as square root of 3 times 3. So what number, that's what the little invisible 2 says, is multiplying itself twice in there? The 3. That's why we get that. Copy that, please. We'll clarify a little bit more with the next example. Hurry up, please. 10 seconds. So pens down, eyes up here. Let me clarify this. What if I wrote, let me see, 27 to the 1/3? Don't copy this, you're just paying attention. Check this out. Think about it. How would you rewrite this in a radical form? Let's see, this one became this, so this becomes 3rd root of 27. Okay. And the 27 I can break down into prime factors by doing prime factorization. What are my first 5 primes? 2, 3, 5, 7, or 11. So which one of those divides into 27? Not 11, not 7, not 5, 3. This becomes 9. I circle a 3. This becomes 3 and 3. So this could be rewritten as cube root of 3 times 3 times 3. And this says the index is asking us, what number is multiplying itself 3 times inside? The 3. Copy that, please. Now it's starting to. All right, let's continue. Here we go. Here we go. Next one. Pens down. Let's see how we can set this one up. 16 to the 1/4. Pay attention, please. Here it goes. 16 to the 1/4. Who thought 4th root of 16? Yes? Okay. So now check this out. Prime factor this one. Which of these prime factors divides into 16? 2, that's 8. Copy that. This is 2, that's 4. And this is what? 2 and 2. Okay. So this could be rewritten as 4th root of 2 times 2 times 2 times 2. So which number repeats 4 times? Because the index is asking for it? The 2. Okay, and with that, I want you to do this last one by yourself. 125 to the 1/3. Okay? Go. Who rewrote cube root of 125? Yes? Okay, from there you found the prime factorizations. Which one of these numbers divided in there? The 5. This is 25, and this is 5 times 5. So this is cube root of 5 times 5 times 5, which is 5. All right, copy this down. Example number 1. Yep. I know, time flies when you're having math, right? Copy those, please. Example number 1. Simplify each expression. A, 343 to 1/3 power. B, 32 to the 1/5 plus 9 to the 1/2. Okay, let's do 8 together. Okay? All right, here we go. Let's rewrite. Our first step is to rewrite as a radical. So, I'm going this way. This becomes what? Cube root of 343. Are we there? And once again, keep in mind your first 5 primes. 2, 3, 5, 7, 11. Remember those? Don't forget those because you're going to need them. So, we need to find prime factors. Does 2 divide in there? No, because it doesn't end with an even number. Can 3 divide it? Let's see. Add these numbers. 3 plus 3 is 6 plus 4 is 10. So 10 cannot be divided by 3. Therefore, it cannot be divided by 3. Does it end in 0 or 5? No. So it has to be one of these two. Let's try 7 first. 343 divided by 7. That fits in there 4 times. 28. Bring down the 6 and the 3. 7 fits in here how many times? 9. So this is 7 times 49. How about the 49? Then you leave it as this. Then it's probably a prime number. Okay, so here we go. This one is 7 times 7. So therefore, this becomes what? Cube root of 7 times 7 times 7, which is 7. Okay, let's do B. Pretty cool, huh? This one becomes what? 5th root of 32. Okay, what does that mean? Then we need to find the prime factorization of this. Let's look at our first 5 prime. Which one of these divides in there? 2. So this is 2 times 16, 2 times 8, 2 times 4, 2 times 2. So I'm going to rewrite it over here because it doesn't fit right underneath. So this becomes 5th root of 2 times 2 times 2 times 2 times 2, which is 2. Okay? And then it says what? Plus, you're like, what? Really? Yeah. Plus, I bring this over here and I rewrite it. How can I rewrite this? Square root of 9, which is rewritten as square root of what? 3 times 3. So what is that number? 3. So this is 5. Yeah? All that work for 5, right? Any questions so far? Yeah, even though it looks like a big number, it's fairly simple to follow. Okay? All right. Here we go. Copy this. Do those by yourself. Okay, get another paper. Or use the inside the Frayer model, since we're not going to use it. Use the little boxes. Hurry up. Here we go. Example, again, 1A. Let's make this 2A. Example 2A. Here we go. Let's rewrite this. What does this become? 4th root of 81. And once again, we start with our first 5 prime and see what we get. Which one of these divides in here? 3. So this is 3 times 27. How about the 27? 3 times 9, and the 9, 3 times 3. So this becomes 4th root of 3 times 3 times 3 times 3, which is 3. Okay? This one. Square root of 121. Which one of those fits in there? 11. This is 11 times 11, so therefore this is square root of 11 times 11, which is 11. Plus. Let's do this one. 4th root of 256. I'm going to do this one over here so I can have enough space. 256 divided by 2 is 128. Divide by 2, that's 64. Divide by 2, that's 32. Divide by 2, that's 16. Divide by 2, that's 8. Divide by 2, that's 4. 2 times 2. Whoa, That's why I wanted to give you one of these. Here we go. So this becomes what? Check this out. This becomes 4th root of 2 times 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 2. That's 8 of them, right? But the index is let me do that in green. The index is asking which number multiplies itself 4 times. Let's see. So box a group of 4. What number is that? 2. But you're saying, but I have another group. Okay, so box that other group, and what is that number? 2. So what is 2 times 2? 4. That's how we get that number. So therefore, what is 11 plus 4? 15. And we're done. Are we there? Okay. Now, the last thing. Eyes up here, please. Pens down. Pay attention. Some of you are thinking, Mr. Q, but that's with a simple fraction. What if I have something like this? Look at this fraction. What if I had a fraction that was 2/3? Can't we rewrite this one as 1/3 times 2? Yeah, right? How about 3/4? Can we rewrite that as 1/4 times 3? Hold on. So check this out. Pay attention, please. Stop putting away stuff, or you're going to miss this. Here we go. If I had 27 to the 2/3, focus, please. I'm going to rewrite this. This becomes 27 to the what? 1/3 times to the second. Are we there? But doesn't this look familiar? Yeah, that becomes what? Cube root of 27, and this exponent multiplies so it stays outside like that. So this becomes, let's see, what is cube root of 27? Isn't it 3 times 3 times 3? So this is 3 to the second, which becomes what? Which becomes 9. 3 squared becomes 9. Copy that, and so you're done. You may leave. Homework for tonight is on page 425. Is that correct? What numbers? 34 to 67. Odd. Have a good one, guys. Enjoy your homework. See you guys tomorrow. Later.